All right, welcome to Unit 2 or Lesson 2.4. So the big difference in this lesson is we're going to have variables, letters, x, on both sides of the equal sign, and we need a new procedure for that. So let's just remind us, in the ones with combining like terms, notice that the x's you had to combine are on the same side as each other of the equal sign. This time x equals positive 11. Okay. So notice in this equation, there is the variable x on both sides. So you cannot combine like terms. What we have to do is do something to both sides to get x on one of the sides. And once x is on just one of the sides, then it's like all the other ones we've done. Right? Our goal is not to get the answer. Our goal is to get x by itself. So we're going to subtract amount of x's there that get rid of them from one of the sides and get them on the other. So think about what you would subtract from both sides here. Well, we're going to subtract 3x from both sides. And let's see what happens. 3x minus 3x, 0, goes away. Cross it out. So all we have on this side is positive 9. 4x minus 3x, right? We're subtracting, so we're going to put a subtraction bar there. And that's x. Done. 9 equals x. Now, why did I subtract 3x rather than I could have subtracted 4x? Different teachers do this differently, but I like to get rid of the x's that are fewer, right? 3 is smaller or fewer than 4. And the reason I like to do that, so that this coefficient here will always be positive when you do that. If you just do either one, sometimes you get a positive x, sometimes you get a negative x, and that can lead to complications and mistakes, right? The more, if you do a whole bunch of problems with positives and a whole bunch of problems with positives and negatives, and you have 200 students, you're going to get more right answers if everyone's doing something with positives, correct? So that's the idea. So I'm always going to get them to be positive. So let's see that. So we have 2x and 5x. So which one are we going to get rid of? I'm going to get rid of the 2x. Cross that out, and right, so you have to do it on each side of the equal sign. You have to do everything to both sides. So we have 5x minus 2x is 3x. 3x plus 8 now equals negative 4. We have a nice two-step. Two steps are, once you get to a two-step, everyone should be very confident at this point. Negative 4 minus 8, negative 12, and x equals negative 4. Now, right, so when you look at this equation, the original equation, right, the only number that I could put in this original equation where both sides end up being equal is this negative 4, right? Both sides there, become negative, was it 8 and negative 12? Yeah, both sides become negative 12. There's no other number that will make both sides equal to each other. That is the solution. Now, which one is smaller, negative 4 or positive 2? Well, negative 4 is smaller. So how do you get rid of a negative 4x? Hopefully you're thinking, well, I should add 4x. Let me get back to different color. So we're adding 4x to both sides. And 18 equals 6x. Divide both sides by 6. And 3 equals x. Right, now if you subtract 2x from both sides, you still get the right answer, but you don't get a nice positive coefficient there. All right, so which one's smaller, -3 or -5? Hopefully you said -5, so we're going to get rid of that one. And you'll know if you've done it my way because you get a positive coefficient here. If you get a negative coefficient, you don't have to, you can keep going with that, but I tend to do it, and I don't just tend to do it, I always do it the other way. All right, so that's the lesson today. Try this one. So 2 is smaller than 7. We get 5x minus 8 equals -4. Right? Once you get to the 2-step, you should be like, well, this is a piece of cake. So 5x equals 4. Divide both sides by 5. Yes, and we can get fractions 4/5. -4 is smaller than 6, so I'm going to get rid of that one. And it's negative, so I'm adding 4x. -5 is smaller than -2. Okay, so now we're going to combine those kinds of problems with the combining like terms problem. So notice we have x's that are on the same side as each other, and we're going to combine like terms for those. And then we have x's on both sides of the equal sign. It will turn out that you want to get your combining like terms done first. Could you do it in the other order? Absolutely. You can do it in any order as long as you do everything to both sides. There's some orders that tend to be easier than others depending on the problem. But generally, not always, but generally it's faster to combine your like terms on one side, then look where there are fewer. Once you realize where there are fewer, you get rid of those and do it that way. All right, so we combined our like terms because they were on the same side of the equal sign. Then we subtracted 2x to get them all on one side. All right, let's try another one. So let's combine the 4x and the minus 6x. So that's -2x. Now what's fewer, x or -2x? -2x is fewer. So we're going to add 2x to both sides. -9 minus 21, right? You can't do that to flip it over. And so that is, right, -9 minus 21, same as -9 plus -21. That's -12. Be careful of that. And so the only number x could be in both, right? It has to be the same in both all 3 locations, right? If you had blank plus 21 equals 4 times blank minus 9 minus 6 times blank, there's only one number that could go in there and make all of that work out. And that number is -4. And if you do all that math, it should come out that the 2 sides of the equation are equivalent or equal. All right, so now we're going to combine distributive property. Parentheses in an equation, get rid of them first thing. Don't even think about it. As soon as you see those parentheses, do some distributive property, right? And then do anything else you need to do. All right, so we did distributive property. There's no combining like terms. We just have to see where there are fewer. 3 is smaller than 5, so we're going to go this way. And x is 14. There's our distributive property. So 15, we're simplifying, we got 15/20ths, we have to simplify the fraction, and it's 3/4. That's it for today. Do both of these. Oh, I had some like terms here. All right, I'm combining steps here. You're allowed to do that. -12 plus 7. So I combined two steps there. I should have combined the like terms first. And as you become an expert, yes, you can start combining steps too, but make sure you're an expert first. All right, so distributive property with fractions with x on both sides. Okay, now we could subtract 1/6 x from both sides, but I'm going to clear my fractions. So what would clear both the 3 and the 6? We're going to multiply both entire sides by 6. That way, so I don't have to, right? Do you really want to do 1/3 x minus 1/6 x? Could you make those denominators the same? Yes, just like with regular fractions. But do you want to do that? Not me. I'd rather just clear them. Oops. Subtract x from both sides and just do the problem with whole numbers. I'm getting 24/5, which is what, 4 and 4/5, which is 4 and 8/10, which is 4.8. Any of those. I'm just going to, whenever I get a fraction answer, I don't want to double check that I didn't mess up. I think it's good. All right, tomorrow we're going to do the same thing, but something funky is going to happen in the solutions.